Hey, how's everybody doing here? We're back once again. We got another week on our hands here, all ready, set to go. It is Learn Math with me, Brian Sapinski. How's everybody doing out there for Tuesday, April 14th, 2020? The date just rolls off the tongue, doesn't it? So, all right. So, here we go. We are ready to start another week of these live stream sessions, any K-12 math help that you want to explore. You know the deal how this works. I have the chat right here on the side where I could see everything. So if you have any K-12 math topic that you'd like to discuss, pop it in right there in the or just wherever it is, down there, off to the side, wherever it is. Just tell me what you want me to discuss as I try to ad lib some things on my own because I'll need your suggestions. They will help me out a great deal. Any K-12 level you want. At the same time, if you're having trouble with typing in the chat, or if you can't type in the chat, you can also send it to me at brian.sapinski@gmail.com. I have my phone on standby. I am ready to take a look at whatever it is that you would like to see. So so I hope you guys give me some good suggestions today. Brianna will be along in a little bit. She's eating lunch and stuff like that. Just trying to just get a couple things out of the way. While I wait for her, there were a couple of things that were coming up between my kids, both my actual kids and a couple of my students that I saw for some one-on-one sessions this morning. That since they're fresh on my mind, I just want to throw them out here and stuff like that. I'll start with my little guy Joey. He always likes to try to get into new apps with on his uh, on his phone and stuff like that. Oh, okay. I got somebody that's trying to pop in there. Uh, oh, wait a minute. Oh, shoot. I forgot to update the link, didn't I? Um, so that my guys can a couple of my guys want to jump in and possibly see the show. So don't mind me. Well, here I'll keep talking while you guys are while I set up the next thing. So no, Joey has a general habit of he likes to try to get new apps, new programs in for on on Andrea's phone, and so occasionally if he wants to try to get to something that we need to give him clearance for, he goes ahead and tries to get in there. Here's the catch though in trying to do that. He um he tried to get around like the password for for in order to be able to get it into the app, and it decided for the thing it said, oh, we're going to give you a math problem and stuff like that. So, and sometimes it gives you an addition question or different things like that, but today it gave him a division problem. So it was like, okay, what so it's like he realizes, oh wait, I can't do division. So it's gonna be like, okay, how do I get around this one? So the question is, how does he do it? So he comes up to me while I'm setting up shop here, and he's like, I know you know math really well. So how do I do this? Um, so very simply, it just asked him to do 15 divided by 3. Okay, so that was exactly the problem that it wanted. So I showed him exactly how to do it, and he got the answer. If you just bear with me 1 second here, and I'll show you what I showed him, because when you're first learning division, it's actually a very good trick to do, and I'll tell you where I got it from at the same time. Da-da-da-da-da. I'm sorry for the silence. Because I'm trying to think, one of my students is trying to watch in and join us and stuff like that to give suggestions. And from where they're trying to get the link in Google Classroom, it tries to say restricted. I got to tell them how to get around that. Okay, well, there it is. Perfect. Okay, so that's it there. Anyway, so here's what I showed him as to how you make division when it's your first time. Several years ago, I have a friend who is a math professor down in Florida. His name is John Nielsen. Hello, shout out to you, Florida John, as I like to call you. And he directed me to a YouTube video that was done by a person. I think I've mentioned it on this live stream once before, but I'll just give this person a shout out again. Um, she goes by the name Heart here on YouTube or whatever, and she has a lot of very creative math videos that she's done for a lot of like wild concepts and stuff like that. It's stuff, a little bit of it's all off the beaten path and things or whatever, but it gets into some higher level, and it's interesting the approach that she takes. However, here's what she ends up talking about with things like multiplication, division, stuff like that. Essentially, she says that all the basic math operations are an example of what she refers to as fancy counting. The idea is that instead, although with the division, the idea is that okay, when you add or subtract, you're either counting forward or backward by ones. So when you do 3 plus 2, you're starting at 3 and you count 2 steps forward to 4 and then to 5. So adding and subtracting, that goes very basic. Now, when you go to multiplication division, instead of counting by and minus ones, you're counting by plus and minus n's or x's, or use whatever variable you want. So in a case like this, as I told Joey to do, what I told him was, okay, if you're dividing by 3, okay, count by threes. So I had him start with 3, and I told him count 3 steps forward from this, okay, and I told him to keep doing it until he gets to 15. So he was able to correctly give me 6, then 9, then 12, then 15. So he was able to get to that. And then what I then told him was, okay, so now you got to 15. So how many total numbers did we write down? And he was able to correctly tell me that there were 5. So that's really the basics of what you can do with this circumstance. Like I said, fancy counting. That's exactly what Vihart, talks about. And it really can, if you, in a lot of cases, like if you could break it down like that, get it down to just your basic, your most primal uh, number skills of just knowing how to count, you can really make a lot of simple math that you don't think you can necessarily do. You can actually zip through it very quickly and stuff like that. So I mean, like, same idea. If you wanted to try to do, okay, let's take a multiplication for instance. If you wanted to do 6 times 7, you could either count by sevens 6 times or count by six 7 times. Either way works there. So if you count by sevens, so you'd go 7, 14, 21, 28, 35, 42. There's the sixth 7, so that would work. Or you count by sixes, you have to count off 7 sixes. So you would do 6, 12, 18, 24, 30, 36. And again, the seventh one, there's your 42 again. So play in either direction that you want there. The the whole idea is that you're using one of the numbers to tell you, you know, what you're counting by, and you have to use the other number to tell you either how many times you have to do it when you're doing multiplication, or with a division, telling you what your goal has to be, and then once you get to that goal, how many steps did you take to reach it. So that's pretty much how it goes there. So I hope that makes sense to a lot of you. And I'll tell you what, only because I'm here, and I'm just thinking of this off the cuff, folks. So while we're here on the whole idea of doing counting lists and stuff like that, um, I don't think we've had any circumstances where we've talked about like greatest common factor, least common multiple, or stuff like that. Or well, okay, I want to particularly talk about least common multiple because I know a lot of people get that fuss here. I see somebody new has popped into the viewing audience. Welcome to you. Please, by all means, throw a topic in the chat out there if you want to see something in particular. But while I'm waiting for a suggestion here in some fashion or another, here's keeping in the fancy counting idea. Okay, what if you want to do something along the lines of trying to get a least common multiple? Now, a lot of people get this screwed up with greatest common factor. Okay, so if you're trying to look for the least common multiple of, say, a 12 and I'll just say, for instance, a 16, for example. Okay, when people think of least common multiple, they get hooked on that first word. They get hooked on the word least. So they're thinking, oh, okay, what goes into 12 and 16? And they'll say the least common multiple is 4. All fine, good. No, wrong. I know least they think of smaller numbers, and I get it. That makes sense. All right. The problem is you're not focused on the L. You're not focused on the word least. You're focused on the M. The M standing for multiple. And the whole idea behind multiple is that you have to recognize multiple means that you have to multiply. And the thing is, when you multiply, that leans into the suggestion that you're going to get into higher numbers. Okay? So knowing that, you have to recognize then, okay, so if you have to get into higher numbers, that means that there has to be a bigger number past 12 and past 16, or usually past one or both of those numbers, that that will get that will be a multiple of both amounts. So here's where the fancy counting comes in again. You want to set up a list where you count by 12s. You want to set up a list where you count by 16s. The first number you find on both lists is the least common multiple because it is the lowest possible number that is a multiple of both things, the common. So you have to break it down like that. So if you were to count by 12s, keep adding 12 over and over again, and you get a 24, then a 36 and a 48, and so on and so on and so on. Now you can stretch out the list as long as you think that you need to. Okay, you might get an idea ultimately of what number in the list is going to work, or if you think you got to go further just to be sure, take whatever approach you want. So let's say I stop here because that's a good healthy amount of numbers. Okay, so try it with the 16. If you add another 16, you get 32, not on the list. So you don't have anything in common yet. So you'd have to add another 16. So if I add another 16 to that, I get 48. And you could see I could stop right here because here's 48, here's 48. So that's the first and therefore the lowest multiple that appears on both lists. So that is therefore the least common multiple. That's how you want to approach it. Okay. So always remember that when you're talking about a multiple, you want to think higher numbers. So you have to count up. It's when you're coming up with a factor that you worry about breaking a number down, splitting up, and things like that. So like I said, multiple, think multiply, think higher numbers. A, for a factor, that that's when you think about dividing or breaking down, and that means that small you want smaller numbers. Okay, so there's the difference between multiple and factor. That's how you want to approach that particular circumstance. Okay, so I hope even then I hope I've cleared that business up with you and stuff like that, because again, I see to this day, I see tons and tons and tons of students that still get the one confused with the other, or they think that both mean the same thing because everybody automatically thinks the greatest common factor. So don't do that. Okay, so try to make that work, for yourself and stuff like that. Okay. Now, speaking of multiples and multiplying here, okay, I got one other thing, and this was and here's something that I was working on with one of my students in a one-on-one session um, in our classroom Zoom before the broadcast today. I want to try to do a couple of I want to do one or two in this topic or whatever. We were dealing. This is in geometry. We were dealing in the concept of similar triangles. So we were looking at a couple of triangles, such as these. Now, understand. Please ignore artistic imperfection. Okay. Hello, whoever is just joining us in the room here. Please feel free to throw something in the live chat if you want to see something. So anyway, the whole idea of similarity is what this student of mine was working on. What similarity basically means, I think we talked in one of the previous live streams. I know it's a little bit back, but in one of the live streams previously, we talked about the idea of figures being congruent to each other. So we talked about congruence where if you're saying that between two triangles, if or any polygons, if they perfectly match each other, all the sides have matching measurements between the two triangles in some way, shape, or form like this, and all the angles match or whatever. Like I said, if everything completely perfectly the same as each other, you could say that these two figures are congruent, and that's all fine and good. All right. But let's suppose that the two triangles have it where all of the angles match. So let's say this angle matches with this one matches with this one, and this one up here matches with this one over here. If all you have to go on is angles, you can't call these triangles congruent. You can at least call them similar. All right. Now, when you have two figures that are identified as similar, what that's going to mean is that one of the triangles or polygons, remember, because this applies to any shape, is a certain amount bigger than the other one, and that amount is always stressed in the form of a multiplication. We use the term scale factor to determine exactly how many times bigger or smaller one figure is compared to the other. So, in the questions that I was doing with my student one-on-one earlier today, she was seeing questions where they were identifying that we had two similar triangles, and the whole idea was that they were leaving one of the side measurements in one of the triangles out. The object was to determine what that missing amount had to be. The key is to find what that scale factor is between the two triangles so that you can calculate your way forward or backward to that missing measurement. So for example, let's suppose that you had a pair of triangles where the measurements look like this. Let's suppose that you had one where the measurements were 4, 6, and 7, like this. And in the other triangle, you had this, you had this, and here the information is missing. Okay, so if the two triangles are identified as similar, what you have to try to do is you have to try to pick out any two sides, one from this triangle and one from this one. You have to pick out anything that are in the same corresponding position. They have the exact same labeled information attached to them. So let's say I use the 4 and the 24. The idea is to get from the small to the big, I have to figure out what is that scale factor. What number do I have to multiply? What number do I have to multiply 4 by to get to 24? That's the key that we need to identify there. And hopefully, see, this is where this is where I wish Brianna was here because I would like to bounce the question off of her and stuff like that because it's a lot easier to play these things out when I have a voice to echo things. But please feel free to throw an answer there in the chat or whatever, just so I don't feel like I'm talking to myself this whole time. Um, so that's the story there. But in any case, hopefully, while I've been bantering here, you'll be able to see that okay, to get from 4 to 24, and hey, even if you're not sure, just do the division. You can do that as well. Okay, so do 24 divided by 4, figure it out that way. Or let's go back to the fancy counting that we're talking about. Count by fours until you get to 24. Whatever way you want to do it, it's entirely up to you. Okay, the bottom line, no matter which way you handle it, whatever way you go about in your head, you should be able to count that you get a 6. So that means the scale factor from the small one to the big one is a times 6. So now that we figured that out, okay, now that we got that in place, the question now is, okay, what amount goes in the blank? So I have to see, okay, this has got the 3 and the 2. Here's the 3 and the 2. So that means this 6 translates to the missing measurement that we've got over there. So we apply the scale factor of 6 from small to big that we have there. So that means to get to that measurement, we would do 6 times 6 to get this amount. And 6 times 6, again, if you know your straight times tables, use it. If you gotta do a fancy counting list, do that. Whatever it is that you want to do, but you should see 36 when everything is said and done. So there's your end result of what goes in that particular measurement. I hope that one is good for you. Okay, now in this example, the missing measurement was in the bigger triangle. What if it's in the smaller triangle instead? So let's see a similar triangle question where the missing measurement goes the other way around. You'll see that there's still going to be a scale factor. Nothing about that is going to change. You just have to be a little bit more careful and clever with how you use it. Okay, so what if, all right, so what if this time, let's say this was the information that they gave you. Let's suppose that they had, let's see, and so I'll make sure I'm picking numbers that work here. All right, so you got that. Okay, and then let's say they give you this, this, and blank down there at the bottom. Okay, so similar nature to the circumstances here. So once again, you pick two sides that corresponds with you pick two sides that corresponds with each other here. So again, let's use the 5 and the 15 for instance. Okay, so if I'm going from the small one to the big one, again, figure out what 15 divided by 5 is so that you can figure out what the scale factor is. And 15 divided by 5, again, if you count by 5s until you get to 15, okay, boom, there it is. And it's the third number in the set, which means your scale factor would be a 3. Okay, so you got that. That's all good. That's all good, and everything's fine there. But now the thing is now to get this missing measurement, it's in the smaller triangle. So the problem is doing a times 3 is not going to help you because that's going to lead to a bigger number. You want a smaller number. So if multiplying gets you to the big triangle, then what operation going the other way would get you to the small triangle? It would have to be a division. So if you calculate 24 divided by that scale factor of 3, you'll get to that particular measurement. So again, you know your times tables, go for it, plop it in. Otherwise, again, fancy counting list time, whatever it is, bump, 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 and there's the 24 that we want. 1, 2, 3, 4, 5, 6, 7, 8 numbers. So that would make 8 the missing side right there. Okay, so that's pretty much the basics there. And this whole idea of scale factors. It doesn't matter what kind of number you end up getting for the multiple. It doesn't matter if it's whole numbers like these were. They could be decimals, fractions, whatever it happens to be. So don't think if the division doesn't work out evenly, it's like, oh, these aren't similar. That doesn't work. I can't have 2.5 or something like that. Of course you can. As long as the scale factor is consistent for every pair of numbers that's in these two similar triangles, it'll work. Okay, so even if, let's say, so here's an example of one where the scale factor is against something different or whatever. Let's say, okay, what if we had one where there was a scale factor of, okay, I'll tell you what I'm going to try to do here. Let's see if I can make this work. I mean, of course I can make it work. I'll see if I can make it up without having to spend 3 minutes coming up with a question. All right. Okay, so so just to show you one where it comes out something different. Okay, let's say if the scale factor is 3/2. Okay, or if you want to call it that, if you want to do division, or 1.5, call it whichever thing you like. So let's suppose that, okay, you had to figure out, okay, let's say that these were the measurements that they gave you in the small triangle. Let's say if they gave you, let's try a 5, a 6, and a 9. Okay, so something like this, for instance. Or, well, do I want a 9? Okay, yeah, I'll leave there. That's fine. Okay, so the idea then is, if you're trying to apply the scale factor to the big triangle, it means all three of these have to get multiplied by 3/2 or by 1.5. Will some of them come out even? Yeah, and some won't. Don't worry about it. It doesn't make a difference. Okay, so I'll start with the one that does work out evenly, and that would be the 6. So when I go to apply the 6 to this one, okay, so handle it whichever way you want. If you're comfortable with multiplying a whole number times a fraction, do it that way. If you're more comfortable with doing the decimal multiplication, do it that way. Whichever way you like, you'll get the same answer regardless. So if you do this, okay, so we do 5 times 6, we get the 0. That gets us the 3 carries over from the 30 that we got. 1 times 6 is 6, plus the 3, we get a 9. There's one decimal place in this one. It's the only one, so I have to put one decimal place in this answer. So there's your solution of 9 even, just to show that it works with this. Whole number times a fraction. Now, I've recommended, I think, again, I said this one in an earlier live stream. You want to try to make sure that, my personal recommendation is, I would do the division underneath first, break it down to smaller numbers to make the multiplication easier to do. So 6 divided by 2 would give you 3 times this 3 that's there already, and there's your 9 again. So okay, so that would make this first one over here, that would become a 9 right there. Okay, now the same thing would happen for the other two. So we see how that plays out. So for the 5, for instance, okay, okay, 5 divided by 2. Okay, we're kind of stuck here. We can't really work our way around that because that doesn't go evenly here, because you have 5/2. Okay, that's the only way it can buy. And either way, then you're gonna have to just multiply across the top. 5 times 3 would give you 15. 15/2. If you left it as a fraction, that would be okay. You can make it a mixed number if you want and call it 7.5. And if you recognize that's 7.5, sure, why not? And you'll get the same thing over here because, okay, 5 times 5, there's 25. Carry the 2. 5 and 1 is 5, plus the 2, and you get the 7. So either way you want to look at it, that would be our measurement there. Okay. And if you do the same thing with the 9, and I'll have you sort of work that one out on your own if you want to and stuff like that. Okay, so 9 divided by 2 would not go, so you just have to do the 9 times 3. You would you would get for you would get for this one, it would be 27 over 2, which if you try to do the division would be the same as if you're doing the 1.5 times 9. Here's 45, the 4 comes over. 9 times 1 for 9 plus 4 you get 13. So you get 13.5 and that's the one there. Okay, so don't get freaked out if you get decimals. Perfectly fine. That's totally allowed. You can do that. No sweat, no worry. The key is to recognize from one to the other. And if you got to do a division between them to see it, that's fine. The key is find that scale factor when you've got two similar triangles. As long as you can do that, everything will make sense, consistently and stuff like that. Okay, so I'm trying to see if I get Brianna up here because just to try to get things put into position. So yeah, be that as it may. All right, so I think we got enough in the similar triangle category and stuff like that or whatever. Yeah. How are you guys watching doing over there? You guys, whoever's watching there, you guys are being pretty quiet there. If you got please by all means, if you got something you want to chime in on, please absolutely by all means, let me know and stuff like that. Okay. So, okay. So what? So what, Brianna? She's she's worried, folks, because she's like, but I got like a Halloween shirt on, wherever the case is. I'm like, okay, big deal. What difference does it make? For as long as we've been shuttered in here, how do we know it's not Halloween? you know. Here, wait, give me 1 second. I'm gonna tell her that. Brianna, Brianna, for how long we've been shut in here or whatever? How do we know it's not Halloween? Don't worry about it. Just come up here. Be silly. That's the point. Please, if any of you guys have been watching any of you guys have been watching up until now and stuff like that, you recognize that, like I said, we are just flying, on the sea of our pants and just being silly in any way, shape, or form and stuff like that. Brianna's artwork usually lends a lot to that humor or whatever. So believe me, as funny as I try to be on my own or whatever, these are a lot better when she's messing around with me up here. So so what? She's still arguing with me down there. Yeah. What am I gonna do with you? Okay. Anyway, all right. Let me see what else I could throw at you guys here and stuff like that. I still like to where and when I possibly can. Again, some of you that have been watching these live streams these these last 4 weeks have know that I've been trying to introduce some different things and stuff like that in the midst of doing the traditional K-12 math and stuff or whatever, that just with the purpose of trying to make sure that to give so you guys see some practical stuff off the beaten path and things like that. So, and try to think of what else I was working on with some of my students earlier today and stuff like that. Okay, I know that one of the concepts here, and I'm going to try to see if I can get a smaller example here so we can demonstrate it properly. Okay, so all right, so follow this. This is so here's the circumstance of what we got here. All right, so let's suppose that you've got. I'm gonna draw a 5-pointed map here. And I'll show you what it is that we're going to be doing with this in just a second. I've done similar maps to this in some of the other. I did one in a previous live stream where I had Brianna mapping out some of the routes that you could take and stuff like that, and she was saying like, "Oh, this is Pac-Man. This is a fish. All that blah 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 blah, all that kind of thing." And yeah, we're gonna get this concept that I'm gonna talk about now gets back into that just a little bit, but there's gonna be a little something extra to this. Okay. So, all right. So you see those. Now, what I'm going to add to this is now this is an example in general of what is called a complete graph. Okay, and I'm going to label these A, B, C, D, and E. Okay, so I'm gonna set that up first. Okay, now the reason why this is a complete graph is because if you look at any one of these 5 points, you'll see that there's an edge connecting that point to any of the other points in the entire picture. So A is fully connected to B, C, D, and E. B is fully connected to A, C, D, and E, and so on and so on. That's how that goes. All right, so, but now with this, because I've drawn this graph before, I did an earlier live stream, but now I'm going to add a little extra detail to it. Suppose I were to throw this in, okay? The numbers that you're going to see, let's suppose that all these 5 were cities and towns that you had to travel to, or major attractions, or who knows what else. Okay, and all these numbers that I'm going to throw in here, these are the distances, whether you want to call them miles, kilometers. Yeah, use whatever description that you like. Okay, it's an 18. Yeah, I'm just trying to draw a couple of these smaller because there's only so much room that I could put in them. All right, so there's an 18 there. Here's a 21 there. Here's a 22 there. Here's a. So I make sure I put these in the right place. No, wait. That 22 is in the wrong place. I'm sorry. This is a 23. Here's the 22, and here's a 40. Okay. The monster arrives. Easy go. Are you okay?
Didn't want to.
Sure. Are you okay?
Didn't want to.
Why? What's wrong?
Didn't want to.
Are you? You feeling okay? Shall we hold our breath until our face turns blue?
Yeah.
So here. Do me a favor. Get here. Answer this one thing for me for a second. Oh, good. Yes. We gotta keep on practicing this and stuff like that because I know this was tripping you up. We'll get to that in a second. All right, here. Answer this for me first. Okay. Now you remember earlier on, I was explaining to the audience when we were doing that. Like I said, you started at A and you had to make your way to all the other spots, and you remember you were making what looked like fish shapes and other sorts of things like that. Or whatever. Okay, same thing, but now there's a little extra purpose. You see all the numbers that I've added to it? Those represent like the distances between those things. And my object is I still want to start at point A, but I want to get from point A, visit all the other points, and get back. And I want to do it in the shortest distance that I possibly can. Okay. So now there's a few different ways to do it. The one that I want to use is what is called the nearest neighbor method. What I mean by that is this. So look at point A. Now, point A is connected to B by this distance, to C by this distance, A by this one, and E by this one. Of those four paths, which one is the shortest distance to travel, hence the nearest neighbor? Okay, so I would go from A to B first. Okay, so that's the first one that I would travel on. Okay, now you're at B. You still got to go to C, D, and E. So follow the line from B to here, from B to there, and from B to there. Who's the nearest neighbor to B? Huh? Wait. So wait. Follow this line. What distance is on this line? Because I think you're reading the wrong number. No, wait. The 21's down here from E to C. Follow this one. What number I have attached to this line? Okay, wait. The 23 is on this one. 23 is on the B to D. So from B to D has got a 23. Okay, B to C we could tell is a 32. But now read B to E. What number's on that line? The 18. Okay, so who's the nearest neighbor out of those three? Okay, from B to E. So we put that in. Okay. Now from E, I've got to go to either C or D. So follow these two lines here. Okay. Who's the short one? From E to C is how long? Okay, and from E to D. So nearest neighbor would be that. Okay. And the rest of the route is spelled out for you because the only place we haven't visited yet is C. So you have to go there next and cover the 25, and then we officially go home to A and hit the 22. So there's our fishy, and we have what is considered our nearest neighbor route. Now the only thing left to do, we just got to total it up. Okay, so we did the 18 first, the 18 again this way, the 9, the 25 along the bottom, and the 22 going back up. So let's get a total real fast. Okay. So let's see, any 10s we could grab or whatever. What we got? Okay, all right, so we get a 0. All right, so we got a 0 there. Okay, so then put the 8, 9, and 5 together. Because we definitely know that's 110. All right, we'll up that as we need to. 8, 9, and 5 give us. Taking a second, just counting the way through here. Hope you guys got an answer. Without a calculator, of course. We got
Unrest and Squidward. Unrest. This is the
I'll tell you what. Maybe we'll tell you what that is. Later. Okay, Joe. All right, Joe. Hey, chill out. How much we got? 8, 9, and 5 will be how much?
Garnet, Unrest, and Squidward.
All right, Joey. Chill, buddy. She's in there somewhere, I promise, folks. What are you worried about?
Guess what? This is a joke. Mrs.
Joey.
Trot.
Joey.
Mrs. Trot.
Joey. Joey. What's 8 and 5?
8 plus 5?
Yes.
I don't know.
Oh, wait. Let's do one better. 8 plus 9. We had to do that for the video. 8 plus 9. That's in your doubles facts.
17.
Okay, add 5 to that. Count 5 forward.
I don't know.
Wait. What's 5 after What's 5 after 17? Count. 18.
19. 20. 21. 22.
Okay, 22. Okay, so we finished with 2. We got 2 more out of it, so that means we're officially. So that means all this counted up to 32. Okay, so bring 3, carry 2. So let's count. So let's count off. How much did we finish with?
We're still recording.
Yes, we're still recording. All right, so finish it off. We got a final total distance of how much? Well, 5 here, and we still have 2 2s.
Your stuff. Listen. Now I'm gonna go watch my.
Okay, so we refer to that as either the total cost, the total weight, total distance, whatever it happens to be. Okay, so that's what it is that we try to come up with or whatever. All right, so that would be the optimal path for this situation, again, by the method that we call the nearest neighbor. Now, there's other ways to come up with these short distances other than this method. There are 2 others in particular, but this is the simplest one probably to describe in any shape or form. So that's another one of the things that we do in the discrete math level and stuff like that. So again, just a little extra, simpler but higher end treat for you guys. Okay, so all right, so let's see what they're giving you here. Okay, dividing fractions and whole numbers. Okay, we've done some things with this or whatever. Okay, so there's been a couple of very comedic YouTube videos they've been watching. I don't know if any of you guys have seen the so this is basically videos. They're a little crazy. They basically take everything about some popular shows and games or whatever and break them down by their most obvious comedic and sometimes incredibly stupid elements that you don't stop to really think about until you stop to think about them. And then you laugh your head off. Okay, so is that you know full well we like to see. I see the smile on your face. I mean, hey, what my goal of trying to teach math to everybody out there and hoping that we could bring some more people to join us or whatever. So think about what my objective is. I would like to meet hundreds of other students with upwards of 3 personalities. So there we go. She's back. All right, let's get
hundreds of other villagers with upwards of 3 personalities.
Okay, let's get to your stuff. Okay, dividing whole numbers and fractions. Okay, so you've got a couple here that we got to make sure that we handle properly in these regards. So let's take a look at some of the numbers here. Like, okay, one example that I've got here. Let's suppose that you have, let's say, okay, I see 1/4 divided by 7. Okay, we talk. Okay, so we talked about dividing by in these fashions before. Well, the division by the whole is the part that I'm worried about. If you're dividing by a whole, okay, well, that results in a number that's going to be bigger than what you started with or smaller than what you started with. It results in a smaller number. And the best and to show it again, that gets into the whole reciprocal concept where we talked about turning if from division to multiplication, flipping it over, that makes it a 1/7. That would confirm it. So you're taking what's already a piece in this case, and it's becoming. Mhm. So there it is. Okay. So we get that. So dividing by a whole, that's going to lead you to smaller amounts there. Okay. But let's suppose it goes the other way around. What if? What if? And I'm just looking for one that has less to worry about here and stuff like that. Okay. Yeah. Okay. So what if you have one that's like this? We've got 4 divided by 1/2. Okay. So now you're dividing by a fraction, that is less than 1, or as I like to call it, a piece. Okay? If you're dividing by a fraction less than 1 or a piece, again, should you expect the number to be larger or smaller than what you started with? This time it gets to be larger. Okay? And while we're okay, well, I'll get to one with it where it's a fraction bigger than 1 in just a second. So again, if you turn this, so and here we'll show this 2 ways to kind of bring everything from the beginning of our conversation full circle. If you turn this over by a reciprocal, 1/2 becomes what? 2/1. Okay, which now whole number times fraction, I would divide by what's on the bottom, but a 1 on the bottom doesn't mean anything. Just give me what 4 times 2 is. 8. So you get 8. Now, that's the one way you can handle it. The other way you could go about this, coming back to what I talked about at the beginning of the video with Joey's question about the fancy counting, is we said that with division means, okay, you're counting in steps of this until you get to that. So let's make the track there. Okay, here's 1/2. If I keep adding 1/2 to that, Brianna, what would I get next? A whole, then
A whole and a
1.5,
half.
2,
2.5.
2.5, 2 1/3,
3.
3,
3.5.
3.5,
4.
and there's the 4. And the question is, so now how many half steps did you take to get to the 4? 1, 2, 3, 4, 5, 6, 7, 8. So there's the fancy counting right there, in there again for you. So that's where that plays out. All right, so that's the kind of thing you want to look for there. Okay, let's see. Any others of particular interest on this one? Any other particular interest on this one? Any significant note? Okay. I can see that. I can see a basic one like that tripping up a number of people, because I bet you anything that seeing a question like that, she was looking at this question right now. 1 divided by 3/5, and I'll bet a bunch of people would look at that and treat that the same way as 1 times 3/5 and say that the answer is 3/5. But no, it is not. No, 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 no.
No. No. No. No. No. No. No.
Ah! Where are the taxes, Isabel?
Why do I always have to pay for everything, Isabel?
Exactly. What actually happens here, you?
You have to flip this.
Right, again.
Oh,
So
no, the eraser.
so it's now 1 times 5/3. Okay, so that would be your real answer here in this circumstance, because we know 1 times anything does what it does. So that's the story on that one. Okay. So we get that. Oh no. Oh no, what did I do to you? Did I break you?
No.
At least I put a smile on your face.
I'm trying. Okay.
I had to bring up the Animal Crossing jokes. How many of you out there are playing Animal Crossing? Because
Me.
these two just started in
I've
this
already
in
made
this
some
past
progress.
in this past week or whatever, and it's
This
they
thing
they
is
they bid into it and they can't stop playing, just like probably none of the rest of you could stop playing. It's probably where some of you some people are instead of here, but but be that as it may, I'm personally not an Animal Crossing guy, so I don't
You seem so into it when you watch me and Joey play it. At the moment,
well
I
I'm just trying to help. I'm just trying to help you when you're swinging your simple and very fragile axe, your flimsy axe or whatever, at the tree,
I made
at the
like I
trees
have
and
the
the rocks and stuff like that. I just want you to save your swings to make sure that you can use them as many trees and rocks as you can and stuff like that.
now
You know what I'm
now I
saying?
have like better recipes for the axes, so that's good.
No, which is
So
fine.
now
Yeah,
they're
no,
like
no,
stronger
but no, but
axes.
no, but you understand what I'm saying, though. You're still limited to a certain number of swings. So the whole idea is that I'm trying to tell you that the moment you either swing at the tree or you swing at a rock or whatever, and nothing comes out, don't swing again. Save your
Well,
swings
I've
for
had
something
moments
else.
where like it like refused, but then I hit it again and then something.
I would usually probably recommend just move on to something else.
Okay. Guess who that is on the board?
Someone whose name you shouldn't Google in the workplace, as it says. I don't know how true that is or not or whatever, and I'm not about to go find out. So I can only probably imagine there's something bad about that, but who's to say? Okay, all right, here, real quick. There's something bad about that, but who's to say? Okay, all right, here, real quick. The rest of this fit into place there. Here, so here.
There we
Here.
go.
Okay, Brianna, let's get the rest of these wrapped up.
Now you'll know who it is. Who is it now?
That don't help me.
It's Isabel burying the taxes, like it shows in the video. Where are the taxes, Isabel?
Go ahead. Go ahead,
They're
real
right
quick.
there.
All right, go ahead, real quick.
So first you have to like flip it
Okay.
to like 12/3.
Okay.
Wait, could we simplify?
Yes, you can. There is a division. The division is right over here. 12 divided by 3.
4.
Total.
20.
Put it down.
3.
Okay.
So that means the answer is 20.
Compete against her. See how you guys do.
3.
Okay.
That's Isabel burying
Okay.
the taxes.
Okay, let's
Remember in the video. It shows Isabel burying the taxes.
2/3 to
I'll make it more obvious.
2/3 divided by 3. Go.
3. 1/3.
That becomes 1/3. Okay. No
answer is 1.
No wait, no divisions to simplify. So we go no the
2/9.
Got it. That's it. Yep. Okay. Right there. How'd you guys do? Okay. What's the next one? 5 divided by 1/3. Okay. Again, you're dividing by a piece. So she
15.
have to turn over to 3. 15 there. Got it. All right. Okay. And we got one more left. So we got 5 over 12 divided by 5. What happens?
Turn this into 1/5.
Okay.
Then,
Can we do any divisions to break it down? Okay. Can we do any divisions to break it down? The two. Wait, no. Wait. Remember, it's got to be a number from the top and a number from the bottom. The 2 5s. 5 divided by 5 would give you
1.
1. So they just go away.
1 up.
There it is. Okay. Boom. There it is right there. See?
Nice.
Okay. Do you need to take a picture of that and send it in? Okay. All right. So
Isabel.
okay. Why don't you go do that? Because come on, it's almost 3:05.
Isabel needs to pay her taxes.
Here for today, and see, I knew I could get her up here and get a good mood out of her. Okay. She was tired. It was just she's tired. I know. She was tired. She's working hard. And I hope you guys are working hard out there too. So I appreciate once again you guys taking your time and coming out to to watch and see stuff like that. Hopefully we helped you with the stuff that we did today. We'll be back here again on Friday at 2 p.m. for another one of these live streams. In the meantime, please hit that thumbs up if you enjoyed what we did today. Throw us a.
You said hit the thumbs up.
She's back. Hit that subscribe button.
I need a subscribe button to hit.
Can't get your computer to work?
Punch it.
So another one of their things. Just go have an extra laugh on us while you go look up. So this is basically. And,
it's the best thing like ever. I love it.
Or trying to be. Well, anyway, move on. Okay. And like I said, so we'll be back on Friday at 2. And sometime between now and when we do our next live stream, there will be a brand new first grade video up with Joey or whatever. Please be on the lookout for it. You're gonna see probably the zaniest thing that we have done in any of these videos yet. Okay, no hints. No, I'm
not.
I don't want them to be. Don't give it away.
I'm not.
Okay. All I will say is it involves a connection. It involves
Jello. It involves Jello.
Well, if any of you that are watching this that have a Facebook account, I do anything related to this channel. I make a public post on Facebook or whatever. So, and those are the only things you can see on my on my wall and stuff like that. If you're on Facebook, and if you look at, aside from these live stream posts, if you see something that I posted on the weekend, you're going to see a mashed up plate of blue Jello. What's it there for? It has to do with there is a connection and something from pop, mathematically related and from pop culture. It involves a one-word connection. Okay, be on lookout, and then just be ready to just hang your heads in laughter, like, what the heck are these guys doing? That's exactly what you're gonna see. All right, so
hit that subscribe button, right? Hit it. I hit it.
Okay, fine. We'll see you guys. We'll see you guys later this week. We'll see you on Friday for the live stream. Sometime later during this week for Joey's next video, and she's gonna be shooting one very soon too. For now, take care. See you guys.
Bye. Bye. Yeet.